Yeah, hello guys. Thanks for joining this session. Today we are going to discuss about the important topic in network layer, okay, which is IPsec. Okay, in the IPsec, in L3 network we don't have any security, right? So most మన ట్రాఫిక్ అంతా between the routers or between the firewalls మన ట్రాఫిక్ అంతా వెళ్ళేది మొత్తం నెట్వర్క్ లేయర్లో కదా. సో ఇన్ ఆర్డర్ టు ప్రొటెక్ట్, ఓకే, in order to protect all our network layer traffic, so we don't have any security protocol. So in order to protect that, this IPsec will be introduced, where this IPsec will be used between the sites, okay, site between the sites, in the sense, okay, let's take you have a company, okay, let's take you have a ABC company, and you have a branch offices, okay, one branch office in Hyderabad and other branch office in Bangalore, okay. సో అలా మనకి మల్టిపుల్ బ్రాంచ్ ఆఫీసెస్ ఉన్నప్పుడు ఆ బ్రాంచ్ ఆఫీస్ మధ్యలో మనకి ఏదైనా ఇంపార్టెంట్ ఇన్ఫర్మేషన్ షేర్ చేసుకోవాలన్నా, అలాగే ఏదైనా కాన్ఫిడెన్షియాలిటీ ఇన్ఫర్మేషన్ షేర్ చేసుకోవాలన్నా, సో వీ నీడ్, ఓకే, IPsec, okay. So this IPsec is called site to site VPN, okay, which we'll also call as a site to site VPN. So whenever you hear a word called site to site VPN, you must have, okay, remember this IPsec. This IPsec will be mostly work between site to site. So whatever I told you, right, this will protect your data or protect your L3 layer traffic between your branch offices, okay. So what are the things that are involved in IPsec means? So here we'll be having, in this IPsec class we are going to cover all these things. The first one, IKE, okay, which is Internet Key Exchange, and what are the phases in the IKE, okay. And we'll be having two phases in IKE, phase 1 and phase 2. In phase 1 we'll be having two modes, main mode, aggressive mode, and also in phase 2 we'll be having only one mode, which is called quick mode, okay. And apart from these IKE modes, we'll be having IPsec modes, where our actual, okay, traffic flowing through this IPsec modes, okay. And we'll be having two modes, where one is transport mode and tunnel mode, okay. And also we'll be having two protocols that we are going to use in IPsec, which is AH and ESP, okay. So I will tell you what exact, okay, how exact how exact information will be shared, okay. So let's take, this is your router, okay. Mostly IPsec will be configured at the edge devices, okay, whether it is a router or whether it is a firewall. So the IPsec will be, okay, configured at the edge devices, okay, whatever the edge device that are available in your network, okay. Let's take, this is your Hyderabad site, okay, and this is the edge of your network, and maybe this is a router or a firewall. And also you have a Bangalore site, okay, you have a Bangalore site, and you will be having one device which is at the edge of the network. So and between these devices will be forming IPsec, okay. And these phases, okay, this phase 1 and phase 2 will be helpful, okay, to build your IPsec tunnel, okay. First the phase 1 will be built, okay, the phase 1 will be built. And once the phase 1 is completed, and it will be going to build the phase 2 tunnel, okay. So once the phase 2 tunnel build, our actual traffic will be there, right. So let's take, okay, you will be having one user here in the Hyderabad site, and also there is some server in the Bangalore site, okay. So let's take, this user needs to access some information which is available in your Bangalore site, okay. So in order to do that, if there is no IPsec, okay, so you are getting some information, okay, okay, we are getting some confidential information from your Bangalore site. So if there is no IPsec tunnel, all the traffic will be flowed in the form of plain text, right. Plain text in sense, whatever you are getting from here, whoever, okay, whatever you are getting from this server, that will be in the plain text. And whoever sitting in the internet, maybe like let's take hackers, okay, or maybe any attacker sitting on the internet, if they capture your whatever the data coming from here, they will able to easily identify what exact you are accessing, right? So in order to avoid that, we are forming an phase 1 and phase 2 tunnel. Okay, this is our whole concept, and we can see how the phase 1 will be built and how the phase 2 will be built. And once the phase 1 and phase 2 build, our how the our actual data will be flown. Okay, మన యాక్చువల్ డేటా ఎలా ఈ phase 1 phase 2 ఎలా ఫార్వర్డ్ అవుతుంది, అలాగే వన్స్ ద data receives on the edge of the device, how it will send out. Okay, so we'll discuss more about that. See here in the IPsec, to send, okay, మనకి ఇక్కడ IPsec లో సెక్యూర్గా డేటా ట్రాన్స్ఫర్ చేయడానికి IPsec will be having 4 features. Okay, one is confidentiality, integrity, authentication and anti replay. Okay, సో మనం ఒక సైట్ నుంచి ఇంకొక సైట్కి మన ఇన్ఫర్మేషన్ని సెక్యూర్గా సెండ్ చేయాలంటే ఈ IPsec వచ్చేసి ఈ 4 ఫీచర్స్ని యూజ్ చేసుకుంటుంది. ఓకే, ఈ 4 ఫీచర్స్ ఏంటి అంటే ఫస్ట్ వన్ వచ్చేసి కాన్ఫిడెన్షియాలిటీ. ఓకే, ద కాన్ఫిడెన్షియాలిటీ, హౌ ద IPsec విల్ బీ అచీవ్ కాన్ఫిడెన్షియాలిటీ మీన్స్, మనం ఏదైతే డేటా సెండ్ చేస్తుంటాం కదా, that data will be encrypted. Okay, so by encrypting the data, the confidentiality will be achieved. So how it is going to encrypt means, and before that I will tell you what is encrypting. Okay, so what is encrypting means, మనకి ఏదైతే డేటా మనకి యూజర్ నుంచి వచ్చిందో that will be in the plain text. Okay, let's take I am sending hi, I am ABC. Okay, it is sending some message like hi, I am ABC. Okay, so this is a plain text, right? So you can able, okay, ఇదే సేమ్ ఇన్ఫర్మేషన్ నువ్వు ఇంటర్నెట్లో సెండ్ చేస్తే వితౌట్ IPsec ఎవరైనా క్యాప్చర్ చేసినా కూడా వాళ్ళు రీడ్ చేయగలరు. ఓకే, రీడ్ చేయగలరు అంటే ఇట్ విల్ బీ ఇన్ ద ప్లెయిన్ టెక్స్ట్, రైట్? సో ఇట్ ప్లెయిన్ టెక్స్ట్ మీన్స్ హూ ఎవర్ కెన్ రీడ్ ఈజీలీ. సో సో IPsec will be used here, okay, to convert this plain text into cryptographic text. Okay, మనకి plain text నుంచి, okay, it will be converted to the cryptographic text, so that the no one in the internet, okay, whenever the edge router convert that plain text into cryptographic, so whoever sitting in the internet, if they capture, they don't know, okay, what is the exact information available. Okay, that is the reason the IPsec device, which is edge of your one site, encrypting the data so that no one in the internet can be able to read or read. Okay, సో ఓన్లీ ద సెండర్. ఓకే, సెండర్ మీన్స్ ఇది మనకి సెండ్ చేస్తుంది కదా, ఇది సెండర్ అవుతుంది, ఏదైతే రిసీవ్ చేసుకుంటుందో అది రిసీవర్ అవుతుంది. సో ఎక్సెప్ట్ సెండర్ అండ్ ద రిసీవర్, నో వన్ ఇన్ ద ఇంటర్నెట్ విల్ ఏబుల్ టు రీడ్ ద డేటా. ఓకే, దట్ ఈస్ హౌ ద కాన్ఫిడెన్షియాలిటీ విల్ బీ అచీవ్డ్. అండ్ ద నెక్స్ట్ థింగ్ ఈజ్ అన్ ఇంటిగ్రిటీ. ఓకే, మనం ఏదైతే ఇన్ఫర్మేషన్ ఇక్కడ ఎన్క్రిప్ట్ చేస్తుంటాం కదా, ఏదైతే ఇన్ఫర్మేషన్ ఇక్కడ ఎన్క్రిప్ట్ చేస్తుంటామో దానికి some hashing value. Okay, it will calculate some hashing value. Okay, let's take it will be calculating 1 2 3 4 5 or something like that hashing value. So that what integrity will be achieved means, whenever you do integrity, it will hash values. Okay, what is the purpose of hashing means, okay, what is the purpose of hashing means, if you hash the data, no one in the internet will be able to modify that data. Okay, మనం ఇక్కడ ఏదైతే హాయ్ ఐఎమ్ ఏబీసీ అని సెండ్ చేస్తున్నామో అది మనం ఎన్క్రిప్ట్ చేసేసాం, ఎన్క్రిప్ట్ చేసి హ్యాషింగ్ చేస్తున్నాం అనుకో. సో ఎవరైనా ఈ ప్యాకెట్ని క్యాప్చర్ చేసినా కూడా వాళ్ళు ఇందులో ఏముందో చూడలేరు, చదవలేరు, అదేవిధంగా వాళ్ళకి మోడిఫై చేయడానికి కూడా రాదనమాట. సో బై యూజింగ్ కాన్ఫిడెన్షియాలిటీ అండ్ ఇంటిగ్రిటీ, no one in the internet will able to read the data, and also no one will be able to modify this data. Okay, no one will be able to modify this data, so by using confidentiality and integrity. So next one is an authentication. So authentication ఏంటంటే మనకి ఈ sites ఉన్నాయి కదా, both sites who are wherever you are configuring IPsec. So before sending the data, మనకి ఇక్కడ ఏదైతే మనం ఈ డేటా సెండ్ చేసినామో, బిఫోర్ సెండింగ్ ద డేటా ఈ రెండు డివైజెస్ ఏం చేసేయంటే దే ఆర్ గోయింగ్ టు అథెంటికేట్ ఫస్ట్. ఓకే, సో వై వీ నీడ్ అథెంటికేషన్ హియర్ మీన్స్, ద అథెంటికేషన్ విల్ బీ హెల్ప్ఫుల్ టు ఐడెంటిఫై from where the data is coming from. Okay, whether you are receiving the data from exact source and receiver. మనకి ఏమైంది, మనం ఇక్కడ నుంచి డేటాని ఇంటర్నెట్కి సెండ్ చేస్తున్నాం. ఓకే, సో మన హైదరాబాద్ సైట్ నుంచి ఇంటర్నెట్కి సెండ్ చేస్తున్నాం. సో మనం ఇంటర్నెట్లోకి సెండ్ చేసినామంటే ఇంటర్నెట్లో ఎన్నో డివైజెస్ ఉంటాయి. సో ఇన్స్టెడ్ ఆఫ్ దట్, ఓకే, ఇన్స్టెడ్ ఆఫ్ అవర్ సెండర్, మేబీ ద రిసీవర్ విల్ రిసీవ్ అనదర్ ప్యాకెట్ ఫ్రమ్ అదర్ డివైస్. ఓకే, మనకి ఎప్పుడైతే ఆ ప్యాకెట్, ఓకే, అదర్ డివైసెస్ నుంచి ప్యాకెట్ రిసీవ్ అయిందనుకో, ఇది ఏం చేస్తుందంటే అథెంటికేషన్ ద్వారా ముందరనే తెలుసుకుంటుంది అనమాట. ఓకే, వెదర్ దిస్ ప్యాకెట్ ఈస్ బిలాంగ్స్ టు కరెక్ట్ సెండర్ ఆర్ నాట్. ఓకే, సో మనం ఆల్రెడీ అథెంటికేట్ చేసాం కాబట్టి ది రిసీవర్ ఏం తెలుసుకుంటుంది, ఈ రిసీవర్ విల్ బి ఐడెంటిఫైడ్ దట్ దిస్ ప్యాకెట్ ఈస్ నాట్ ఫ్రమ్ ద ఎగ్జాక్ట్ సెండర్, సో ఇట్ విల్ బి డ్రాప్ దట్ ప్యాకెట్. ఓకే, so authentication will be helpful, okay, to authenticate, okay, each other, so to identify whether we are receiving the packets or whether we are receiving the data from exact sender and the receiver. Okay, both will authenticate each other. Okay, that will be helpful for, okay, that helps the authentication. And last one will be having anti replay. Okay, anti replay, even though we have, okay, even though we have we have encrypted and we have authenticated and we have hashing all the information, maybe there are some hackers who are sitting in the internet with advanced tools. Okay, they are sitting with the advanced tools. They are going to, okay, they are going to crack our information even though we have encrypted, even though we have we have hashed our data. Okay, so they are doing some, they are using some advanced tools and they are going to crack our data. So even though we have, okay, even though the attackers using some advanced tools and they get our information and they are trying to modify, right? So whenever they modify, okay, and this, okay, with the authentication, this sender and the receiver will also exchange some sequence numbers. Okay, so once the information is, okay, let's take, once information is sent from this sender to the receiver, so along with the data, okay, along with the packet, it will be sent one sequence number. Okay, let's take, this is the sequence number is 123. So it's sent to the internet. So whenever some attacker sitting in the internet, they will try to modify that or try to change something, this sequence number will get changed. Okay, let's take 123 will become like 345 now. Okay, okay, now this 345 packet will receive on this receiver. What will check, it will check the, by using anti replay, it will check the sequence number. Okay, it should be same as how what the sender sends. Okay, the sender sends with the sequence number of 123, but the receiver receives 345, right? So now the what the receiver will think that, so this three sequence number is not matching what, okay, the and okay, what the sender sends, so it will be considered it as a duplicate and it will be dropping that packet. Okay, so whenever they are going to authenticate, they will exchange some, they will exchange the sequence numbers. So once the sequence number matches, then only the receiver will receive that packet. Okay, otherwise, where if something has changed in between or something, okay, someone has access our packets in between, this sequence number will get changed. With a change sequence number, if the packet received with the changed sequence number, the receiver will not accept that. It will be considered as a duplicate and it will be, okay, it will be dropped here. It won't accept. Okay, that's how the IPsec will helps our sites in order to secure our data. Okay, even though the attacker sending some information, okay, with modifying data, the receiver will not receive. Okay, using these four features, the IPsec will secure our data. Okay, so we are going to use all these features, okay, in the phase 1 and phase 2, and we'll see how, okay, how the phase 1 is going to use and how the phase 2 is going to use. Okay, so these are the some protocols. Okay, okay, we have discussed about encryption, right? So how the how the firewalls or edge devices going to encrypt means using these methods. Okay, we'll be having DES, 3DS, AES are the three encryption methods where it is going to use. And we have also discussed about hashing, right? So this is the MD5 and SHA are the two hashing methods. Okay, these are going to hash the our data. Okay, and Diffie-Hellman group, okay, this is a Diffie-Hellman which is which is also used for hashing. Along with this, along with this integrity, the DH group will be also used. So this is also has our data. Okay, where whenever the you see the DH, okay, will be having some value. along with the DH group, okay, we'll be having some value 1 2 5, okay, and now we'll be having DH19, okay, and we'll be having DH20. So why we have numbers means here, the higher the number, it will be hashing the more value, okay. It will hash very it will, okay, whatever the data we are hashing, that will be, okay, okay, that will hash very strong, okay. It will calculate more hashing value, so that whoever going to whoever going to crack the data, they will be not easily being cracked, okay, using this DH group, okay. Higher the number, the greater the hash value and greater the security, okay. The DH value, you have to remember that the DH number will be greater, okay. If the DH number will be greater, the greater the security in our IPsec information, okay. And we have an two protocols where we are going to use in IPsec, okay, once the phase 2 is completed, ESP and EH, okay. So these ESP and EH will be used after forming an of tunnels, okay. Once you form IPsec tunnels between our sites, okay, let's take this is a phase 1 tunnel, okay, and this will be an phase 2 tunnel. And once the phase 1 and phase 2 tunnel will be formed, this ESP and EH, okay, any one of the protocol will be used to send our user data, okay. This will be encrypted in the ESP packets, and it will be sent through the tunnel, okay. We'll discuss more details about this going forward, okay, in the next slides. So now we'll be going to, okay, we will be going to see what is internet key exchange. So IKE is an protocol, okay. We have discussed about IPsec, right? IPsec is also a protocol, and also IKE is also a protocol. The IPsec will be use this IKE protocol for forming phase 1 and phase 2 tunnels, okay. IKE is a protocol where it is going to use for forming and phase 1 phase 2 tunnels. So in the phase 1 we have discussed about modes, right? Main mode and aggressive mode. So we'll discuss more about that in the next slides, about main mode and aggressive mode, and we'll be having the quick mode. Sorry, in the phase 2 we'll be having quick mode, okay. So what will happen in the main mode, and what will happen in the aggressive mode, and what will happen in the quick mode, okay. We'll discuss more about that. Before that, let's see this. These are some, okay, pictures that I have taken from the internet. So how the phase 1 tunnel will be formed. So this is your edge router, okay. You will be having edge router, one edge router, let's say this is a Hyderabad, and this is a Bangalore, okay. And we will be having IPs, right. So using this, you will be forming an IPsec tunnel phase 1. Once this phase 1 tunnel will be formed, this phase 1 tunnel will be used mainly for the management traffic, and also to send an IPsec phase 2 information, okay. Once the phase 1 tunnel will be formed, then only, sorry, once the phase 1 tunnel will be formed, then only phase 2 tunnel will be formed, okay. If this phase 1 tunnel will not form, okay, and this phase 2 tunnel will also not be formed. So this phase 1 will be mainly for IPsec to form, okay, and to carry our data, okay. Once the phase 1 tunnel, okay, once phase 1 tunnel formed and phase 2 tunnel formed, and our actual data will be there, right. This is our actual data, okay. Actual data means if you are sending some information from user in the, okay, let's take this is a user in the Hyderabad site, and this is any of the server that is going to connect. So whenever you are trying to ping, or whenever you are trying to access something here, right, so that is our actual data, okay. Our actual data will be flown inside the phase 2 tunnel, okay. The phase 2 tunnel will be formed, okay. Okay, the phase, once the phase 1 tunnel will form, and after that the phase 2 tunnel will be formed. If the phase 2 tunnel formed, our actual data will be flown inside the phase 2 tunnel, okay. This is how this is how the structure will be, okay. This is how this IPsec phase 1 phase 2 will be formed, and once the phase 2 tunnel completes, our actual data will be flown from end devices, okay, to from the source, okay, from your source user to the destination device, or whatever they are going to access, okay. This is how the architecture will be, okay. And see here in the phase 1 we'll be having, okay, we'll be having two modes. One is a main mode and one is an aggressive mode, okay. So once we discuss about once we gone through main mode and aggressive mode, we'll discuss okay which mode we are going to use in the phase one. Okay, we'll be having two modes. Okay, we are not going to use two modes at a time. We can use only one mode. So once we complete main mode and aggressive mode, okay, you will come to know which mode will be going to use between our site to site. Okay, so first we'll go with the main mode. Okay, in the main mode we'll be having six messages. Okay, six messages always. Okay, it's from three messages from the sender to the receiver and three messages from the receiver to the sender. Okay, like we'll be having just a minute. So you will be forming IPsec phase. Okay, you will be forming IPsec tunnel, right, between our sender and the receiver. So this is a sender and this is a receiver. Okay, and the first message will be always flown from the sender. Okay, first message from here, and second message from here, and next third message from the sender, and fourth message from the receiver, and fifth message from the sender, and sixth message from the receiver. Okay, so likewise in the main mode we can see the six messages. So what exactly we'll be having in the six messages? Okay, in the first message, okay, in the first message we are going to, okay, we are going to send parameters. Okay, whatever the parameter that we have discussed. What we have discussed? We have discussed about encryption, right? We have discussed about encryption, hashing, right, authentication, and DH group. Apart from this we'll be having lifetime. Okay, we'll be having lifetime. Okay, these are the five parameters that are going to exchange in the first message. Okay, so obviously here I need to mention one thing here. Whenever you are forming an IPsec tunnel between your sites, so this IPsec will be use an UDP protocol. Okay, it will use an UDP protocol. Sorry, it will use an UDP protocol with port number 500. Okay, if you see a UDP protocol with port number 500, okay, both source port and destination port will be 500 here. So both will be both source and destination port 500 500. Okay, so this is a protocol that IPsec will be going to use. I will show you here. See here, this is a UDP, user datagram protocol, which is a source port 500 and destination port 500. If you see this source port, destination port 500 500, you can blindly go with the IPsec. Okay, which will be calling as an IPsec protocol. So in the IPsec, in the first message, it is going to exchange these parameters, whatever the parameter that we are going to, okay, that we are going to, that we have already seen, right? That is going to exchange between the in the first message from sender to the receiver. Okay, so first one is an encryption, hashing, authentication, group, DH group, and lifetime. Okay, these will be calling as an security association parameters. Okay, we'll be calling as an SA parameters. We will be calling as an SA parameter, which is called security association parameters. Okay, here will be why we are going to exchange this means. So the first, the sender will send this all the parameters in the first message, and in the second message the same parameters, okay, whatever the parameters that we have configured in the receiver, so it is also going to exchange. Okay, why we are using these parameters means to form an phase 1 tunnel. Okay, to form an phase 1 tunnel, here we'll be forming an phase 1 tunnel, right? To form an phase 1 tunnel, all these parameters should match. Okay, whatever the parameter that we are exchanging in from sender to the receiver and also receiver to the sender should match. Okay, every parameter should match whatever the we are seeing here at the five parameters. Okay, so one is encryption, hashing, group, authentication, and lifetime. These parameters should match. Okay, if the parameters are not matching, the IPsec phase 1 tunnel will not form. Okay, see here in this picture, whatever I am using here, this is an encryption AES. It is using AES CBC, and it is also using AES CBC, right? And hashing, it is going to use SHA, and it is also going to use SHA as an hashing algorithm. And authentication, what it is going to use authentication as PSK, and it is also going to use an PSK. And the group DH group, it is using 1024 bit MODP group, and it is also okay, this is also using MODP DH group, right? And the lifetime, it will be using 86400 seconds, okay, 86,400 seconds, and it is also going to use 86,400 seconds, okay. All these parameters should match to form, okay, to form phase 1 tunnel. If any of the parameters are not matching, let's take you are using SHA here, okay. Here in the second message from the receiver, right, this here you are using SHA, but here you, instead of SHA you are using MD5, okay. Instead of SHA you are using MD5. This is not matching, right? This hashing algorithm, here we are using MD5 and here we are using SHA. So in this case, this hashing algorithm is not matching. So if any of the parameters mismatches, you cannot form IPsec phase 1 tunnel, okay. To form an phase 1 tunnel, all these 5 parameters should match, okay. That is one thing you have to remember. In order to form phase 1 tunnel, all 5 parameters should match. Whatever the parameters that we are using here, all the parameters should match, okay. So these parameters should be exchanged in first 2 messages, and in the third message, whatever the, okay, DH group we have discussed about, right? Here it is okay, it is negotiated or exchanged here, but actual hashing value, okay, it will be going to hash, right? So that key exchange, okay, whatever the hashing value that we are going to use, so it will be exchanging in the third and fourth messages, okay. This is third message, and this is the fourth message, okay. This key exchange needs, okay, this key exchange will be exchanged in third and fourth message, and the fifth and sixth message, there is some identification information will be shared, okay, in order to identify what exact receiver and exact sender. So they are going to send some identification information. In this identification information, it will share some private IP addresses, okay, private IPs, or they are going to share some user credentials, okay. So in that case, the it will include in the fifth and sixth messages, and it will be sending, okay. Before sending that, these are the private IPs and user credentials, right? These things are the sensitive information, okay. These are the sensitive information which is not, okay, supposed to send, okay, which is not supposed to send in the internet without encrypting, okay. That is the reason our whatever the information that is including here in the fifth and sixth messages, the IPsec is going to encrypt the data, okay. So if you open, okay, if you open IPsec message 5 and 6 in the main mode, you can see the encrypted data, okay. You can see here, this will be shown as an encrypted data, where you are not able to see what exact information that is available in the identification, okay. Actually in the identification, we are sharing some private information of the sites, and also some user credentials to authenticate. So these are the things that they are going to use for the identification. So this will be an some exact, okay, these are the things that are not, okay, that are not exposed in the internet. That is the reason it is going to encrypt, okay. In the fifth and sixth messages, it is going to encrypt, okay. And these are the 6 messages that are in our main mode, okay. In the first 2 messages, it is going to exchange the parameters, SA parameters, and in the third and fourth message, it is going to exchange some key exchange values, and fifth and sixth message, it is going to exchange identification information, okay. In the identification information, it is going to send some private IP address and the user credentials to identify, okay, exact sender and the receiver. So these are the sensitive information, right? So that is the reason it is going to encrypt the data, okay. So these are the 6 messages that are included in the main mode of phase 1, okay. And next we'll be having aggressive mode. So in this aggressive mode, like how we have 6 messages in the main mode, in the aggressive mode we have only 3 messages, okay. We have only 3 messages, like how we have, okay, 6 messages in the main mode, we'll have 3 messages here only, okay. So how then, if you have 3 messages, how these IPsec feeds that are going to exchange all the information means, So whatever we are sending, okay, whatever we are sending here in the 6 messages, it is going to share, okay, in the aggressive mode, it is going to share in only one message. Okay, see here, we'll be having you will be having these parameters which we are going to share in 1 and 2 messages. We'll be having key exchange which we are going to share in third and fourth messages before. And also here you can see identification data. Okay, identification data which we are going to share in fifth and sixth message, right? It is going to share in the first message itself. If you see here, this identification, whatever identification data you are seeing here, it is not encrypted here. Okay, you are seeing some IP addresses, right? But whenever you see in the main mode, you cannot see what are the exact information that are included in the identification. In the main mode, it is in the main mode, whatever the IP address or credential that it is going to share, it is encrypted. But in the aggressive mode, you can see here, it is not encrypted. Okay, it is not encrypted, it is sharing as is how we have configured. Okay, so in the this is the first message of aggressive mode. Okay, this is first message which is going to send from sender to the receiver. Okay, first message will be sent, and the second message also the same thing. Okay, in the second message from the receiver to the sender, it will also having the same thing. Okay, this SA parameters, key exchange, okay, and identification number, identification information. Okay, and also the key hashing value. Okay, the key exchange value will be shared in the second message from the receiver. Okay, and the third message you can also see here. Okay, it is also sharing some identification information which is sending in the plain text. We are seeing it, right? The data 192.168.12.2. So it is also sharing 192.168.12.2. It is also sharing the same information, so that is not encrypted, right? So why it is not encrypted? Okay, why it is not encrypted here, and why it is encrypted here, in the sense because of the secure method. Okay, and in the third message, it will be having just and simply, okay, just this simply dummy message, it is going to exchange in the aggressive mode. Okay, so we have discussed in the phase 1, we have discussed about main mode and aggressive mode, right? Main mode and aggressive mode. So if you put the points, okay, if you put the points in the table, okay, you will be having 6 messages here, right? You will be having 6 messages here, and aggressive mode have 3 messages, and main mode is an slow process. Okay, main mode will be is a slow process because it has to be process all the 6 messages. That is the reason the main mode is a slow process, and aggressive mode is a fast when compared with the main mode, right? Because it has only 3 messages to process, so it will be processed very fast when compared with the main mode. And main thing here is that main mode is a secure method. Okay, main mode is a secure method because fifth and sixth messages where we are going to, okay, send some identification information will be encrypted, but in the aggressive mode we are not going to do that. That is the reason it is not secured. Okay, so not secured. The aggressive mode is not secure because the identification information is not encrypted. So if you come, okay, if you take a, okay, if you are configuring IPsec phase 1 between the, okay, IPsec between our sites, we are going to choose main mode. Okay, so in the phase 1 we will be having aggressive or a main mode. So whenever you are configuring IPsec between your sites, in the phase 1 you have to select main mode because the main mode is a secure method where fifth and sixth messages are whatever the identification information that we are sharing, it is going to encrypt that. Okay, that is the reason main mode is a secure method which we are going to use on phase 1. Okay, you can also aggressive mode. Okay, you can also use aggressive mode. So if you, okay, if you think we need less secure, okay, if you think we need fast process but we need only a less secure method, so you can opt for the aggressive mode. Okay, aggressive mode will also be used, but security wise it will not provide much security. Okay, so that is the reason everyone in the phase 1, okay, whoever configuring IPsec in between the sites, they are going with the main mode. Okay, so these are the things that you can, okay, that you can see in the phase 1. And next we'll be having phase 2. Okay, In the phase 2 we'll be having only one mode. Okay, we don't have any option here. In the phase 2 we'll be having only one mode, which is an quick mode. Okay, which will be an quick mode. So once the phase 1, okay, now we have exchange. Okay, we are using main mode and we have exchange 6 messages and everything is fine. We have formed an, okay, we have found phase 1 tunnel. Okay, we have found phase 1 tunnel. Once the phase 1 tunnel formed, okay, once the phase 1 tunnel formed, this phase 1 tunnel will be help to exchange our phase 2 information, right? Whatever the phase 2 information that we are exchanging between our sites, this is site 1 and site 2, or Hyderabad site and Bangalore site, it will be flowing. Okay, all the phase 2 information will be flowing through your phase 1 tunnel. Okay, and in the phase 2 also you will be having three messages. Okay, it is also negotiate three messages: first message, second message, and third message. Okay, so all these three messages are encrypted. Okay, do anyone tell why all these? Okay, in the quick mode of, okay, phase 2, all the three messages are encrypted. We cannot see anything here. Do anyone have a guess why these three messages are encrypted? Anyone?
because already mode 1 access చేసాం కాబట్టి
Yeah, that's correct. We have already formed phase 1 tunnel, right? We have already formed phase 1 tunnel, and what we have discussed, this phase 1 tunnel will be help to send our phase 2 information, right? That is the reason we are already formed a tunnel. Okay, we are already formed a tunnel means we have already doing encryption here. So that is the reason we have already phase 1 tunnel. All our phase 2 information will be flowing inside the phase 1. That is the reason we are, okay, we are seeing all the messages of phase 2 are encrypted. Even though it is, okay, even though it is encrypted, to form an phase 2 tunnel, okay, we are also going to exchange some information here. So these are the parameters that they are going to exchange. Okay, these are the parameters that they are going to exchange in the first two messages. Okay, here the first message and second message. Okay, we cannot see exact information here, but these are the parameters that they are going to exchange in the message 1 and message 2. Okay, so what are those parameters? Means it is going to use IPsec protocol. Okay, we have discussed two protocols, right? ESP and AH. So we can use any one of these, and it will be going to exchange between your sites. Okay, I will tell you which one is going to use, whether it is using ESP or AH. Okay, and also you will be having encapsulation mode. Okay, we have to also discuss about transport mode. Okay, we haven't discussed, but we'll discuss in the next slides. We'll be having two transport mode, oh sorry, encapsulation modes. One is an transport mode and other one is a tunnel mode. And apart from that, it will going to exchange encryption method, authentication method, lifetime. Okay, and DH. Okay, DH is an optional, and if you want to use, you can use, otherwise no need. But all the above parameter, all the above five parameters is going to exchange. Okay, the first one is an protocol. Okay, the first one is a protocol. So in the IPsec we'll be having protocols. Okay, two protocols, which is first one is an ESP. Okay, and other one is an AH. Okay, what is ESP and what is AH? Means ESP means encapsulation security payload. Okay, encapsulation security payload. So why, what is encapsulation security payload? Means whenever you are using ESP as a protocol, it is providing, okay, encryption, okay, and authentication and integrity to our data. Okay, I told you, right, once we form phase 1 and phase 2 tunnels between our sites, our actual data will be flown inside the phase 2. So how the phase 2 will be, how the data will be flown inside the phase 2 means using these protocols. Okay, you can see our, okay, let's take phase 1 tunnel formed and also the phase 2 tunnel form. Okay, whatever the user data comes, okay, comes here, and it will be flowing inside the phase 2 tunnel. Okay, so how it is, the phase 2 tunnel is forwarding this traffic means using these protocols. Okay, whether you, if you configure ESP will be having as an our payload. Okay, you can see the, if you take the packet capture, you can see L1 packet, L2 packet, or L2 header, L3 header, and L4 header. After that you will be having data. Okay, what is exa data means? This is a ESP payload. Okay, this, if you are using ESP, this data will be having ESP as a payload, and if you are using AH, you will be having AH as a payload. Okay, so here we are discussing about ESP, right? ESP is an encapsulation security payload, where it is going to, okay, this is actual data. Okay, it is going to provide authentication, integrity and encryption to our actual data. Okay, while AH is an authentication header. Okay, AH is an will be calling as an authentication header. So it is only providing only authentication and integrity only. It is not going to provide encryption. It is only providing authentication and integrity. It is not providing any encryption. Okay, so even though we have phase 1 and phase 2 tunnel, some people will be there to grab our information, right? Even though they grab our information, our actual data will be secure, because, okay, if you are using ESP, okay, even though our, okay, some attackers, okay, broke our phase 1 and phase 2 tunnel and grab our information, this ESP will be there in order to protect the data. Even though the attacker stealing our data, ESP will be there to protect. Okay, if you configure ESP as a protocol, ESP will be there to protect our data, because ESP will be providing encryption. Okay, but AH you can also, okay, you can also configure AH as a protocol, but it is not going to encrypt the data. It is just providing authentication and integrity. It is not going to provide any encryption. So if the people are, okay, broke our phase 1 and phase 2 tunnel, they are going to steal our data, so they will be easily be, okay, identified. Okay, so to form, okay, whenever you are forming phase 1 phase 2 tunnels, okay, in the phase 2 you are going to use ESP between site to sites, because ESP will be providing encryption while AH is not providing encryption. Okay, ESP will be used between our site to site. Okay, and you are talking about protocols, right? So if you're talking about protocols, every protocol will be having its own protocol number, right? So ESP will be having protocol number of 51. Okay, so ESP will have the protocol number, sorry, it is a 50. ESP having a protocol number 50, and AH will be having a protocol number of 51. Okay, if you see in the, okay, if you see this here in the internet protocol, you will be having an protocol, right? So in that case you can see the protocol as an ESP. Okay, these are the protocols that we are going to see in the IPsec. So one is an ESP, other one is an AH. ESP will provide encryption, along with that it will also provide authentication and integrity, but AH will not, okay, providing encryption. It is going to only provide authentication and integrity. Okay, so we are going to use ESP while forming, okay, IPsec between our sites. Okay, because of extra layer in security. Okay, and see here, and we'll be having modes. Okay, we'll be having two modes, which is transport mode and tunnel mode. So how, what the transport mode will do and what the tunnel mode will do means, so we are sending some information, right? We are sending some information between our sites, right? So whenever you are sending some information, it will be sent in the form of packets, right? So we'll be having L2 header, L1 header, L2 header, L3 header and L4 header, right? After that we'll be having the our actual data. Okay, so these transport modes and these tunnel modes are going to use along with our protocols. Okay, if you are using ESP and if you are using AH, we are going to use these protocols along with that protocols. Okay, so if you are using transport mode, okay, so whatever the information that we have received from the user, it is not going to, okay, it is not going to modify anything, or it is not going to add any extra information. How the data comes, okay, how the data comes from the user, it is sending as it is without modifying anything. Okay, let's see. Okay, you have got the information. Okay, this is our original packet. You have, okay, IP header, TCP header and the data, and before that you will be having L1 and L2 also. So we are mostly focusing on IP header, right, which is L3 header. So it has shown here like in that way. So we will be having IP header, TCP header and data. Okay, so this is our original packet. Whenever you are using transport mode, it is not going to add anything here. Okay, this is a protocol. Okay, this is a AH header is a protocol. Obviously if you are using AH, it is going to add AH header, Apart from that, it is not going to add any extra information to the, okay, to our actual traffic. So it is not going to add any extra information to our traffic. But if you are using tunnel mode, okay, see here we'll be having tunnel mode. If you are using tunnel mode, you can see a new extra IP header. Okay, this is our original packet, and this is our tunnel mode packet. Okay, whenever you are using tunnel mode packet, it is going to add new IP header. Okay, new IP header, where it is going to provide okay, where it is also going to provide extra secure for our original IP header. Okay, what this original IP header contains means, okay, so here you will be having one IPsec device in phase 1, right? One IPsec device, other one is on one other site. Okay, so what exact information will it contains means, so this IP header, okay, this is our original packet, right? Original packet means this is our original, okay, exact source. Okay, this is the source and this is the destination, right? This original IP header will contains our private information. Okay, where the traffic is, okay, where the traffic is generated and where it is going to destin, right? So this IP header will contain information about our private networks. Okay, this is our private network and this is also private network, right? So whenever you are using transmode mode, the this IP header will not get, okay, will not get added anything extra. But whenever using tunnel mode, so once this traffic comes here, okay, here also we'll be having one IP source. Okay, you will be having one IP, and here also we'll be having one IP. Okay, so with for this, okay, for this new, okay, for this original IP packet, it is going to add new IP header here. Okay, so this is our, okay, this is our original packet and this is our new IP header. Okay, this new IP header contains this IP address as a source IP, this IP address as a destination IP, which are both are public. Okay, because it is both are connected to the public. Okay, let's take, we'll be having internet here. So these are the two IP address which we have public IP address. So whenever you are using tunnel mode, okay, our actual IPsec peers that are going to, okay, add new IP header. Okay, what new IP header will contain means, these IP address, whatever the IP address that we have configured here to form an IPsec tunnels, we'll be calling as a tunnel interfaces as well. Okay, whatever the IP address are there in the tunnel interface, that is going to add in the new as a new IP header. So whoever, okay, whoever trying to access or to whoever trying to steal our information, they will be getting only information of this new IP header. Okay, this information will be encrypted. Okay, this information will be encrypted with this new IP header, so that whoever stealing the data, they will get only this new IP header details. Okay, which will be having public IP address. If you are there, if they are stealing public IP address, there is no use of, okay, if they get any public IP address also, there will be no use. So that in that way, this tunnel mode will also help to protect our original packet. Okay, and apart from encryption, okay, apart from ESP and AH, we'll be also having modes where it is going to helpful to protect our IP header. Okay, mainly our main focus is to protect our L3 traffic, right? These are the things that we are going to use in the IPsec, and to protect our L3 information which are going to share between our Hyderabad site and Bangalore site over the internet. Okay, so these are the things that that we can see in the IPsec. Okay, and we have mostly covered everything. Okay, and we have covered IKE, main mode, aggressive mode. In the main mode we'll be having 6 messages, right? And we'll be having 3 messages here. Main mode is more secure, right? And aggressive mode is less secure. And main mode will be having main mode is a slow process, aggressive mode is a fast process. But in the quick mode we'll be having 3 messages, where all the 3 messages are encrypted, because it is flowing inside our phase 1 tunnel. That is the reason 3 messages, okay, 3 messages are encrypted. Even though it encrypted, it has to be exchanged, okay, all the parameters. So here I forgot to tell you one thing, how these parameters are matching in the phase 1. in the phase 2 also all the parameters should match. Okay, so if you are using ESP on one side, you have to use ESP on other side. If you are using AH on one side, you have to use AH on other side as well. So like how if any parameters is mismatched, the phase 1 tunnel will not form, right? In the same way, if any of the parameters are mismatched in the phase 2 also, the phase 2 will not come up. Okay, the phase 1, we can form phase 1 if the parameters is mismatched, and we cannot form phase 2 if the parameters are not matching in the phase 2 negotiation. Okay, and if the phase 2 will not form, our actual data will not be flown inside our through our tunnel. Okay, so to form or to send our actual data, the phase 1 and phase 2 are necessary. To we need to have both phases up, then only our traffic will be flown. Okay, and I think what else, and we have discussed transport one tunnel mode. Okay, mostly here you can, if you see here, from the phase 1 we can use main mode. Okay, after that we'll be using quick mode. Okay, and after the quick mode, what we are going to use, we are going to use an ESP with tunnel mode. Okay, because we are more concerned about our L3 traffic, right? So in order to protect our L3 traffic, we need more secure methods. So these are the secure methods in IPsec. If you form an IPsec between the side to side, you are using main mode in the phase 1, quick mode in the phase 2, and ESP as a protocol to carry our data, right? To our actual data will be in the form of ESP packets. Okay, once you form main mode and aggressive mode, you are going to send some data, right? So let's say you are pinging from here. Okay, you are pinging from 10.10.10.1 to, let's take this is, you will be having 20.20.20.1. so whenever you are pinging from here to here, you can see ICMP request packet, right? So that ICMP request packet will be encrypted inside. Okay, inside this ESP payload. Okay, in the ESP payload you will be having this ICMP request packets and reply packets. Okay, so you cannot see these ICMP request and reply packets because you are using ESP where it is going to encrypt your request and reply packets. So if you are using AH protocol, you can obviously see what is, okay, what you are exchanging here. Okay, you can see ICMP request and reply packets here. Okay, so this is how the IPsec will be used to protect our data and to form and secure tunnel. Okay, to form a secure tunnel between our sites and to send our data securely between our sites. Okay, and these are the things that we can cover in this IPsec. Do you have any questions or do you need any clarifications on this? Any question or any clarification that you need?
Clarity and
Okay, others?
clear, bro.
Okay, good. If you are clear, we can, okay, I will show you the, okay, just bear with me for next, okay, 10 to 15 minutes. I will show you the lab. Okay, and we'll be also having configuration as well here. So we'll be having configuration as well here in this PPT. Okay, this PPT is already uploaded in your, okay, if you are accessing our website, this PPT is already uploaded, so you can go ahead and grab this PPT, and we'll be having, okay, configuration as well in this. So what are the things that we need to configure in the R1, and what are the things that you need to configure in the R2? So mostly this IPsec will be configured mostly on the firewalls. Okay, in the real-time scenarios, this IPsec will be found mostly on the firewall because firewalls are the edge devices that are sitting. Okay, and you are mostly focused on the, in the CCNA you are mostly working on the routers, right? That's why I took routers here. And if you come, okay, if you are in the real-time scenarios, mostly this IPsec will be configured on the firewalls. There are multiple firewalls, right? We'll be having Palo Alto, FortiGate, Checkpoint, all those firewalls. So whoever using Palo Alto, okay, they are forming IPsec tunnels between your Palo Alto firewalls and exchanging your information. Okay, but you are mostly for in the CCNA, you are focused on the routers, right? So that's why I've taken the routers here and I have configured. And what are the configurations means here, the first thing you are seeing the policy one, right? ICMP policy one, that is for the, these are the information for phase one. Okay, these are the informations of phase one, and whatever the information, okay, phase one parameter that you are using here, the same thing you are configured on the other router as well, because to form a phase one you have to match the parameters, right? So all the parameters should match whatever you are configuring here. Okay, and after that you have to create an access list. Okay, I think you have also, we have also covered the access list in the bootcamp, it seems. So you can also configure access list. Okay, why we need access list means, here we have to tell, okay, whenever you receive the information on the routers, okay, whenever you receive the user information on the routers, you have to tell to route this traffic through the IPsec tunnel. Okay, through the IPsec tunnel. So that is the reason we have to create an access list. Okay, we are creating an access list and we are permitting, okay, whatever the subnet, this is, okay, this is 10 dot subnet and this is 20 dot subnet. So you have to permit this 10 dot subnet and 20 dot subnet in the access list. And what you have to tell is this access list. Okay, what is the access list? VPN traffic, right? So this access list, we are creating some crypto map, and we are, okay, crypto map is like, we are mapping all. Okay, we are forming phase one. Okay, phase one parameters, phase two parameters, and also we are forming an access list, right? So to form, okay, to, okay, we are calling, okay, we are combining all this phase one phase two parameter access list in the crypto map, and to map everything on the one of the interface. Okay, so we are mapping this crypto map on this interface, so that what it will do means, all the traffic that is flowing, that is coming from your user, okay, it will check the, okay, it will check the access list, and it will see on which interface it has to be flow. Okay, here we are using gigabit ethernet 3/0, right? So it will check the ACLs and it will check whether it has to permit or not, and if it is permit, it is permitting to the gigabit ethernet 3/0. And in the same way we have also configured here. Okay, we have created phase one, we have created ACLs, and we have created phase 2 parameters, and we have created crypto map, and this crypto map will be mapping on this gigabit ethernet 0. Okay, crypto map is like combining everything in an one thing. Okay, in an once. Okay, phase 1, phase 2 and ACLs, combining everything in an one crypto map, and that crypto map will be mapped under this gigabit ethernet 3/0. Okay, whenever the traffic comes, it will be flowing through the IPsec tunnels, where where the tunnels are formed on this gigabit ethernet 3/0. Okay, so this is a configuration that we have on the document, and also you can use this configuration to form IPsec tunnels. So I will show you now. I have GNS3. This is already, okay, I have already configured and I have formed this IPsec tunnel. So I will show you. Okay, I have already shown the configuration, right? So you can use the same configuration to configure in R1 and to configure in R2. So I will show you the verification part. Okay, I will show you how we can verify the things. I will take the packet capture and I will show you what are the exact information that we are going to exchange between our router 1 and router 2. Okay, so this is my, okay, this is my topology, where we are going to use R1 and we are going to use R2. Okay, and we'll be having, okay, PC1 connected to R1 and PC2 connected to R2. Okay, now I have configured phase 1, okay, phase 1 parameters, phase 2 parameters, and I have configured ACLs here on both the routers, and that whatever the things that we have configured, I have created in one crypto map and assign all those in the crypto map, and configuring that crypto map on the Ethernet 3/0. Okay, on the Ethernet 3/0 on both sides. Now whatever I am doing, okay, whatever I am doing here, I am just verification part. So I will show you the things here. So here to okay, if you want to see the configuration, you have a command show. Okay, you can see show running config section crypto. Okay, if you use a crypto as a keyword, you can get all the information. Okay, these are the information: IPsec phase 1 and IPsec phase 2. Okay, and I have created a crypto map and assigned that crypto map and the gigabit ethernet 3/0. Okay, and I have configured same thing on the this router as well. This is my Hyderabad router and this is my Bangalore router. Okay, and the Bangalore router as well. I will check show running config section crypto. If you configure, then only it will show under the crypto section. Okay, otherwise it will not show. I have already configured, that is the reason it is reflecting here. And I have also configured everything here pre configured. Okay, so once we configured and everything is fine, right, to form an IPsec, okay, to verify IPsec phase 1 tunnel is up or down, you can use show crypto ICMP SA. Okay, ICMP SA is the phase 1. You can see here nothing is there. Okay, destination, source, state, and nothing is here, right? And if you see show crypto IPsec SA. Okay, IPsec SA is an phase 2 tunnel. So now here we can see gigabit ethernet and the local addresses and everything is fine. But if you see here, inbound ESA, outbound ESA, inbound AH, outbound AH, nothing is there, right? Because there is no traffic is flowing, so that it is not okay, it is not found. Okay, here one thing you have to note down is, whenever you are forming IPsec phase 1 and phase 2 tunnel for the first time, okay, whenever you are forming phase 1 and phase 2 tunnel first time, it will not come up that easy. Okay, it will not come up it will not come up instantly. So in order to come up, you have to send the traffic inside the tunnel, then only the phase 1, okay, the tunnels will come up. Whatever that, what are the traffic that you have to mention, whatever the traffic that you have to flow is, so these are the traffic. Okay, whenever you are pinging from PC1 to PC2, the traffic flown inside the tunnel, then only the tunnels will come up. As of now, we are seeing no information is available for phase 1 and phase 2, right? So now what I will do is, I will generate a traffic from PC1 to PC2, and before that we can check whatever the if the IP address are available here in the PCs or not. I think these are the virtual PCs where we are not seeing any data. So I will just check show IP, no IP address, right? So to configure IP address on VPC, so you can just give the command IP 10.10.10.10 and subnet mask 255.255.255.0 and the gateway 10.10.10.1. Okay, that is my gateway. This is my gateway, right? So I configure 10.1 and it is going to configure IP address. Okay, so it is going to check for duplicate IP addresses. If no duplicate IP address found, it is going to assign the IP. Okay, show IP. Now we got INP, right? And the same thing I can do here. Show IP, we have 00, right? So IP 20.20.20.20 255.255.255.0 and default gateway is 20.20.20.1. Okay, so do anyone know which protocol is going to use to find the duplicate IP addresses? Do anyone know which protocol is going to use to find duplicate IP addresses?
Gracious.
Gracious up.
Yeah, that's correct. So whenever you are assigning IP, it is going to send gracious or to find duplicate IP addresses. If you get reply, it will consider that it has a duplicate IP and it is not going to assign. If you are not getting any reply for that gracious or, it considers this IP address is not in use and it is going to assign. Okay, that's correct. Yeah. Now Now I'm going to do is I'm going to ping from PC1 to PC2. Before that, I will capture the packets here. So these are the IPsec. Okay, we are forming IPsec tunnel between Hyderabad and Bangalore, right? So you have to take the packet capture between the routers so that you can see whether the phase 1 tunnel is formed or phase 2 tunnel is wherever you get. Okay, whenever you see anything, whenever the traffic is flowing, you can see where it get exactly causing issue. Okay, if you are causing any issues, you can take packet capture and you can see if phase 1 tunnel is forming or if phase 2 tunnel is forming. You can see that. Now what I'm going to do is I'm going to initiate the traffic here. Okay, from PC1 to PC2 I'm going to initiate to. Okay, I'm going to ping 20.20.20.20. No, the first packet will be timed out, but we have seen the response, right? So now we have seen the response. Let's check if phase 1 comes up or not. ICMP is okay. Before we haven't seen any information here, right? We haven't seen any information here. Now once, okay, we have seen that. See here we have seen the IPsec phase 1 state and phase 1 information here. Okay, see here the status is active. Okay, if the status is shown as an active, the phase 1 tunnel is up. And you can also check the IPsec crypto, sorry, IPsec SA, where you can see the information in the ESP. Okay, inbound ESP. So we are using ESP packet. Inbound ESP means whatever the traffic coming inside your router. Okay, from here, from the PC1 to router, you can get inbound ESP. Outbound ESP means it is sending information from this side. Okay, and also you can see inbound ESP information and status is active, and also outbound information and the status is active. Okay, so this is how you can verify the phase 1 and phase 2 tunnels. And you can also check the same thing here as well. Okay, show crypto ISACMP SA. So you can see same thing here. Okay, status is active, and also show IPsec, show crypto IPsec SA, and you can also see the same thing here. Okay, and also you have to identify. Okay, when okay, if the phase 1 and phase 2 is up, so you can see the status is active on both sides. Okay, so you can see one issue here. Okay, you can see one issue here. The phase 1 is up and phase 2 is up, but traffic is not flowing. Okay, in that case what you have to verify is you have to verify the packets encapsulation and packets decapsulation. Okay, so what I told you in the phase 1 and phase 2, so whenever we are sending a traffic out, right? So whenever we are sending an traffic out, here it is going to encrypt the data, right? Yeah, here we are seeing encryption, right? So whenever we are sending the data, the router is going to, here the router is going to encrypt the data. Okay, whenever the router encrypt the data, this encryption, okay, this encryption bytes will increase. Okay, and also we can receive the data from here, right? So we can receive the data from here to the router. So whenever the router receives the data, it is going to decrypt. Decrypt means it's again reverse process of encryption. Okay, it will decrypt at that time. The decryption bytes will increase. Okay, so you have to identify whether the firewall is sending the data or firewall is receiving the data or not. Okay, so by encapsulation bytes you can see the firewall. Okay, if you see the encapsulation bytes are increasing and decapsulation bytes are not increasing, you can say that our firewall, okay, our router is sending the data but we are not receiving the data from the other side. Okay, and here also in the same way you can also check here as well. Okay, so here we'll be having packet encapsulation and packet decapsulation. Okay, encapsulation means we are sending the data out. Okay, decapsulation means we are, okay, we are receiving the data. If your encapsulation bytes is increasing and decapsulation bytes is not increasing, we can say that we are not receiving the data. Okay, but if you are, okay, if you are not sending the data but only you are receiving the data, means that is issue with our firewall. So you have to, okay, issue with our router, and you have to verify what are the steps that we did wrong. Okay, and that is the one thing that you can verify whether when traffic is not flowing. Okay, you can, okay, in the IPsec mostly you can see the phase 1 is up and phase 2 is up, but my traffic is not flowing, like that they will say. Okay, so that you can use this command to check whether encapsulation bytes and decapsulation bytes are increasing or not. Okay, and these are some okay, these are the two verification things that you can see on the IPsec. And we can check the packet capture now. Okay, I will stop capturing for now, and we can see whether our phase 1 phase 2 packets okay, phase 1 phase 2 messages are exchanged or not. Okay, see here. See, I haven't configured any main mode or aggressive mode, okay, but the routers have taken main mode. Okay, so basically, whenever you are creating whenever we are creating an IPsec tunnel between one side to other side, it is going to take in main mode, obviously. Or if you have an option to configure, you can configure main mode. Okay, but in this case, I haven't configured main mode. Anywhere I have configured main mode, but the routers, okay, the routers they have chosen main mode. Okay, so see here in the main mode of first message. Okay, this is the first message from 1.1 to 1.2, which is our from source to the receiver. Okay, so in the first message, what we can see the L2 pack, L3 packet. Okay, and you can see the user protocol. Okay, user datagram protocol, where you can see the source port is 500 and destination port is 500. Okay, and after that you can see the SA parameters. Okay, this is the ICMP protocol, where it is going to see the identity protection is main mode. And if you want to check the parameters, go with the association parameter, security association parameters, open the proposal, and also open the transform. Okay, once you open the transform set, you can see the parameters configured here. Okay, encryption, hashing, group, authentication. Okay, and the lifetime. Okay, that should be same on the both sides. Okay, this is from the sender, and the second message is from the receiver. Okay, has anything changed? If you are seeing anything got changed, nothing, right? So if you're not changing anything here in the protocols, so everything is matching. That is the reason we are seeing phase 1 tunnel is up. Okay, and in the third and fourth message, you can see just an key exchange, where it is going to exchange the hashing value. And if you see on the fifth and sixth messages, the identification. Okay, it is going to send the identification. So identity, okay, identification, which is encrypted. Okay, we cannot see anything here. Okay, and this is the fifth and sixth messages. Once the phase 1 tunnel is formed successfully, once you see the 6 messages, it is going to the phase 2. In the phase 2, all the messages are encrypted format only. If you see here, everything is an quick mode, and everything is an encrypted phase. Message 1, message 2, message 3. Okay, so after that we are sending in our actual data in the form of ESP packets. See here, one, how many ESP packets? 1 2 3 4 5 6 7 8. Okay, why we are getting 8 packets? Means we are pinging from PC1 to PC2, right? How many packets we send? 4 packets we send. Okay, 4 packets we send means 4 ICMP request and 4 ICMP replace, right? That is the reason we are seeing 8 ESP packets, one ESP packet for request and one ESP packet for reply. Likewise, we are sent a 4 packets. That is the reason we are seeing 8 ESP packets. Okay, so all 8 ESP packets will be can see. Okay, in the Internet Exchange Protocol, you can see it as an protocol as an ESP, encapsulation security payload, which is the protocol number 50, and the source IP, destination IP. In this payload, you can see the information, but we are using encapsulation security payload, right? We cannot see any information here. Okay, if you are using AH, you can see the information. What is the, okay, what is the request? Okay, what is the source IP? What is the destination IP that you are sending? That you can see here. But we are using ESP, right? We cannot see any information here. Okay, this is how you can identify the, okay, you can check the packets, and you can capture the packets, and you can verify the things, whether what are the things you are going to send from one side to other side. Okay, do you have any questions? Or this is all about IPsec. This is all about IPsec. Do you have any questions, or do you have any clarifications that you want here?
Yeah. So what is in a real time issues that we see in the IPsec tunnel, and how do we identify?
Yeah, here in the real time scenarios, one issue I have idea. Okay, one issue I have notified here. Okay, you can see phase one, phase two tunnels are up, but traffic is not flowing. Okay, so whenever the tunnels are up, even though tunnels are up, traffic is not flowing. Okay, there may be chances of maybe issue with the fire. Okay, issue with the routers, or issue with any of the intermediate device where the devices which are not blocking your IPsec traffic, or you haven't configured right access list. Okay, you are sending some information with the source IP 10.10.10, but you haven't mentioned
Hello,
the subnet here in the access list, you haven't
Karthik.
permitted. Yes,
Uh,
yes, someone is asking something. Hello,
yes, we are not unable to hear your voice clearly. It's breaking.
is it everything you are everything is facing same issue or only Alekia?
Yeah, yeah,
No, bro.
everyone.
Yeah, yeah.
Yeah, okay.
Now it's fine.
Now it's let me okay, let me share. Stop presenting and I will share only one window. Yeah, I have heard this from multiple peoples before also. So whenever sharing my entire screen, there is some okay issue with my voice. Let me share only one screen. Okay, one window. You can see my window, right? And you can able to hear me clearly, right?
Yes.
Yeah, okay. See here, mostly you can see the issues like okay, the phase one is up and phase two is up, but traffic is not flowing. In that case, what you have to do is okay, as I told you, you have to check encapsulation bytes and decapsulation bytes are increasing or not. So if encapsulation bytes are not increasing here, okay, encapsulation means we are encapsulating and sending the traffic. Okay, if the that bytes are not increasing here, so we are not sending the traffic out. So the issue with our router or the firewall. So if you are using router, you can check whether you have correct access list configured or not, and whether you are permitting the correct subnet or not here. Okay, so if you are not receiving, okay, if the decaption bytes are not receiving here, okay, and you maybe that issue with the other side, maybe any intermediate device that are stopping your data. Okay, so in that case you have to verify in this firewall, and you have to verify the same thing, whether encapsulation bytes and decapsulation bytes are increasing or not. And encapsulation bytes are not increasing, you have to verify the same thing access list here. And maybe if you are not receiving, okay, if the decapsulation bytes are not increasing, and this firewall is not sending the data, or this firewall is not, even though this is sending, the Bangalore firewall is okay, the Bangalore router is not receiving, maybe any of the intermediate device where it is blocking our IPsec traffic. And also one more thing here as well, whenever we will be having, okay, whenever we will be having IPsec, okay, IPsec peers, and whenever you will be having any NAT device in between, okay, NAT device where you have enabled the PAT, okay, port address translation, these are IPsec or L3 traffic, okay, carries L3 traffic, but whenever you see the NAT device in between, this will be allow only IPsec traffic, sorry, L4 traffic. So this will conflict. Okay, this is L3 traffic, but we are using L4 device here. This L4 device will not, okay, will not allow our L3 traffic. Okay, so in that case also you can see the traffic is not flowing. So for that purpose we will be having a separate concept of NAT. I think everyone has heard about NAT. I think mostly we have also covered it boot camp for IPsec with NAT. So whenever you have NAT devices in between, so this will be our L3 traffic will be not allowed on the NAT devices, so that you have to enable the NAT on both the IPsec feeds. Okay, this is a one issue that you can see, and other ones like phase one is not coming up, and also phase, even though phase one is up and phase two is not coming up, like that you can see. If the phase one is not coming up, mostly that will be based on the parameters. Okay, if any of the parameters are not mismatching, or if the authentication is not mismatching, okay, that will be causing, and phase one is not coming up. And also the phase two is also same thing. Okay, if the phase one is up and phase two is not coming up, that will also depends on the parameters only. parameter in sense whatever the parameters that we are going to exchange between our sites, those you have to check whether we have configuring same parameters or not.
Okay. And any appliance dependency, like let's say that when we are configuring two identical appliances, so
Mm.
the configuration maybe goes smooth, but
Yeah.
in a real time scenario that you would be having a different set of router models, right?
Yeah, if
Like
yeah, go ahead. Yeah, understood your question.
yeah, or a firmware also, if you can say that that one site may be
Mm.
maintaining a latest one, another site
Mm.
maybe is waiting for a validation and all. So
Mm.
it maybe version mismatch and all. Is that also is causes any problem on the IPsec
No, no,
networks?
this IPsec will not depends upon the any firmware or appliances. This mostly depends
Hmm.
on the whatever the parameter that you are using. So if you are using one firmware here and another firmware here, both will be supporting the parameter, the same parameters only. So that will not depends on the any appliances or firmware. That mostly the IPsec will mostly depends on the what parameters that we are configuring in both the routers.
Understood.
Yeah. Any other questions, guys?
In a real time, in a main site and brand site, so they would be using a multiple technologies, right? So
Mm.
for a main site, they'll use SD-WAN, IPsec, MPLS, and all.
Mm.
So in that situations, do we have any typical commands to be keep it in hand to troubleshoot kind of an IPsec issues?
Uh, Commands wise, not required typical commands. Just whatever the things that we have seen here, we can use that. Whatever we have using in this lab, okay, you can use that same commands to identify the issues on the IPsec. There is no
Okay, so
such typical commands to identify the issues on the IPsec.
okay, so in terms like it's a full if we can understand the concept end to end,
Mm,
whatever we discussed today.
mm, mm.
So overall, that would be helpful in order to trace out the issue.
Yes, that's correct. Yes.
Okay, thank you, Karthik.
Yeah, no issues. Yeah. Guys, any other questions?
And one more question, Karthik.
Mm-hmm.
That it is again a real time.
Okay.
So let's say that I'm so we are working for a client,
Mm-hmm.
and where it is all works on the vendor dependency, right?
Mm,
Clients and all. So let's
mm,
say that that we are extending a LAN to the vendor.
mm,
The vendor has a different set of protocols are being used
mm,
in their network, and
mm,
their complete network is not in a our control.
mm,
So when we are extending our LAN to vendor for some kind of an ODC, let's say in a consulting term, like if you are working for a Wipro,
mm,
and when we are working for a client, they say, okay, we'll build our own ODC,
mm,
and that particular ODC have the client network, right?
mm, mm,
So in this typical scenarios, right? So when we are doing this IPsec tunneling
mm,
between the two brand sites,
mm.
so let's say that if they are using it like how these in case like do we have any typical configurations would involve when we're dealing with the two different vendor networks?
No, actually, these two vendor networks, it is not okay. It not depends upon the two different vendor networks. So if you want, okay, if you are configuring IPsec, okay, these are the general configurations where every vendor will support. Okay, so this is not typically depends upon the vendor. Okay, and if you want, okay, this mostly depends on what type of traffic you have to, okay, you have to send through the once that IPsec tunnel will be formed, what type of traffic we have to send through the tunnel, that depends. So this not mostly depends on the vendor things. Okay, every vendor will support IPsec where it will be the configuration will be same on the every vendors.
Got it. Got it.
Yeah. Guys, any other questions?
ఇప్పుడు నార్మల్గా ఇప్పుడు ట్రబుల్ షూటింగ్ లో మనం ఫస్ట్ పారామీటర్స్ చెక్ చేసుకుంటాం కదా బ్రో, ఫస్ట్ నార్మల్ గా అంటే ఎర్రర్స్ ఏమైనా ఉంటే
అవునవును.
తర్వాత మనకి ఎన్కాప్సులేటింగ్ డీకాప్సులేటింగ్ బైట్స్ చెక్ చేసుకొని ఫర్ సెండింగ్ అయితే ఎన్కాప్సులేటింగ్ చెక్ చేసుకుంటాం, ఫర్ రిసీవింగ్ అయితే
Decapsulation.
డీకాప్సులేటింగ్ బైట్.
That's correct.
యా
Yes.
యా బ్రో, యా దట్స్ ఇట్.
Yeah. Okay.
థ్యాంక్ యూ బ్రో.
Okay. Okay. No issues. Yeah.
Very good session, Karthik.
Yeah.
Thank you.
Yeah. Thanks for your feedback. I think if you don't have any questions, we can wind up this session here. And tomorrow we'll be having a NAT session at the same time. Okay, please join the NAT session as well. We can discuss in the same way. So this comes to end with our IPsec. Okay, thanks guys. Thanks for joining. Happy weekend. Bye.
యా థ్యాంక్ యూ బ్రో, హ్యావ్ ఎ గుడ్ డే, బాయ్.
Bye.
Thank you.
Thank you.